for a few years in this area. Uh, I've been working for a few years in this particular area, and I'm going to share with you some of these thoughts uh, because I'm very, very excited about some of the things that are happening. Uh, Sangwen mentioned about the project at PCL. You can consider that what I'm going to talk is one important aspect of that progress. And that is how do we decide what to eat, or how do we recommend people what they should be eating? Now, on surface, because you live in a city like Hong Kong, which is very well known for food, you can think that it's a very easy decision. But in my opinion, it's a really very interesting and complicated decision. So I'm going to tell you a lot of things that you all know. They will sound to you very obvious, and most of us, because from the day we were born, we have been interested in eating, and we have been eating. So we are all in a way expert in eating. But I will try to bring a slightly different perspective, and I'm looking forward to your comments on some of my thoughts at the end, or if you have some question in between, please feel free to ask me that question. Okay, so with that, let's go and start seeing uh, about quality of life. About 70 years ago, Maslow started talking about this pyramid. And he said that quality of life of society and every individual in the society can be determined based on certain factors. And those factors are really, what do we need? And he started arguing that all the needs can be put in the form of a pyramid. In this pyramid, the important thing is, first, your basic needs related to physiological needs have to be satisfied. If they are satisfied, then you go to the safety needs. Once your safety needs are satisfied, then you go to the next level, belonging, then go to self-esteem, and so on. When you look at this, the most interesting thing that you find is that you immediately find that the first and the most important need that each of us has is food. Nothing happens without food. Okay? And that's what we want to talk about. So the first question that comes to mind is, why is food so important? Why do we give food so much importance? And the answer to that lies in simple things. In order to live, we have to eat, because food provides us energy, it provides us nutrients, but most importantly, it provides us enjoyment. Many people live so that they can eat wonderful food, they enjoy eating, but there are some people who like to eat to live. They want to eat only things that are required, that will give them correct energy and nutrients. Most of us do not belong to one or the other class. We all believe that food is life, and we want to both enjoy food as well as we get energy and nutrients from the food. Okay. So a question that commonly occurs to mind is, do we want to live long, or do we want to feel that we are living too long? It's a very interesting question. When you start thinking about this, you start thinking about lots of very interesting aspects. And I will be able to address some of those aspects here today. Of course, After introducing the topic, I will jump into and start discussing here some of the technical aspect and how technology is going to help us solve and address some of these problems. Most of us don't realize that the biggest component of human society is food. Yeah. Food occupies more than 50% activities of humans. Starting from food production, which is agriculture and farming, to distribution of food, to food processing, to marketing the processed food, etc., going to grocery stores, buying things, going to restaurants, eating things. That is the consumption part. And finally, how do we recover some of these wastage? That means if you think about the food cycle, almost every aspect of society is concerned with food. And if you start trying to create a network, look at this complicated network. This is prepared by food departments at the different places, and this shows you how different aspects of society are related in a food related network. We don't have time to get into this, and we don't want to get into this, but let me mention, how would a politician view food? Just think about, do politicians even worry about food? Well, one of the most important politicians who is respected a lot in United States and all over the world is Henry Kissinger. And what Henry Kissinger said is very revealing about politician thinking. He said, control oil and you control nations. But you control food and you control the people. Very interesting. Some years ago, I started partnering with some of my friends in Chinese Academy of Sciences, and we started analyzing what is the role of food from the computing perspective. And we came up with some ideas. We packaged those things in a review paper or survey paper, published it in ACM Computing Survey. This paper was called Food Computing. And in this paper, we defined that food computing applies computational approaches to all aspects of food, starting from perception, recognition, retrieval, recommendation, and other activities related to this. It brings in many different aspects of these things. This paper, for the first time, convinced me, though I was convinced about importance of food, and that's why I was trying to get into this kind of things. And I had started working about food computing. But while working on this paper and one more paper with the subset of some people from Chinese Academy of Sciences, my good friends Hui Ting Min and Su Chiang Jiang, particularly, that's when I started realizing that there is a lot more serious research from technology side, from data side, the type of things that we people in this room normally do is really required, and that could be revolutionary. And that's what I want to share with you today. The first thing that occurred to me was that we define food computing in this particular way. And I was defining the food computing in terms of how much part of the society it is there, how different these aspects are. But can we look at this from entirely different perspective? I call it person-centric food computing. When we start thinking about this, for a person, there are two aspects: my body, my physiology, my biology, and the second aspect is, what do I enjoy? And these two aspects are both are equally important to me. But in terms of food, at the next level, when I consume food, either I use packaged foods, I use recipes to cook something there, I go to restaurants, or I use different devices in my home to start cooking some of these things. At the next level, you start considering food chains, from where the food comes: agriculture, grocery stores, different types of food processors and distributors, and different wholesalers. Last cycle is carbon footprint of my things that I would eat, how much water it consumes, am I violating animal rights, how do I recycle food. Now, when you look at this diagram, for the first time, you start realizing that our food habits affect the whole environment. Our carbon footprint, the global warming phenomena, can be changed significantly by changing our food habits. Much of the global warming is the result of our food habits. That's why in the last few years, people are talking about this artificial meat, impossible meat, and impossible burgers, and all this kind of things. Yeah. So it is very interesting to see that what we do can affect society so much. The second interesting thing about this is, it is not only that it will affect the society, but it also is very interesting that people, even hundreds of years ago, started saying, tell me what you eat and I will tell you who you are. Very interesting. Just based on what you eat, they can start telling you this. And that's because food is the most important factor in our life. Think about any social occasions. Different festivals are associated with different types of foods. Different social occasions are associated with different types of foods. Yeah. Okay. So when you start thinking about people coming from different religions tell you what to eat or what not to eat. Enjoyment is obvious. Biological impact of food is very well known. But the impact on business and agriculture and all these things I had mentioned briefly. So we start thinking that all these things are related to food and they are important. But currently, they are all live in different silos. They are not connected to each other. Using computing techniques, we can start breaking those silos and start really understanding the interdependence of different aspects of these and start solving some of these problems. So, one of the most important things that many of us enjoy, I particularly enjoy, is that food is a major source of enjoyment in life. But we also know that it is also the most effective medicine. Hippocrates, something like 3,000 plus years ago, said our food should be our medicine and our medicine should be our food. I'm sure in my audience here today, most of you know that Chinese medicine, Ayurveda, or any of the traditional medicines also argued the same thing. In different seasons, under different conditions, what kind of food you should consume, because that serves as medicine. And when you think in scientific terms, that's not surprising. As this was the cover of Time magazine, few years ago. Same message. Ultimately, food is nothing but combination of chemicals. So is medicine. So no, it is not surprising that the two things are related. After this general thing, now let me mention to you a practical problem. Unfortunately, I am not sitting in Hong Kong today, but suppose that I was in Hong Kong. If I'm in Hong Kong, I will face two problems. What are those two problems? Problem number one, how do I get there? For example, from my hotel to conference center. This is particularly difficult in place like Hong Kong because Hong Kong is one of the very few three-dimensional cities. Yeah. Even in two-dimensional places, even in rural areas, going from one place to the other becomes sometimes a challenging problem. This is the first problem. The second problem is, what do I eat and where? And this problem could become really, really, really interesting if I have diabetes or I have allergy, or if I'm a vegetarian or vegan, or I'm a very picky eater. I grew up with the food habits of Indian. I want to eat only Indian food. Like many of my Chinese friends, they will go to Paris and they are looking for a Chinese restaurant in Paris. Nothing wrong. It is just our culinary profile. Okay? And maybe I have only 1 hour of time. And finally, I'm on a tight budget. So how do I solve these problems? I'm sure most of you have realized that whenever you go to a place, these are the two problems that you face. Luckily, in the last 10 years particularly, this problem has been solved. How do I go from my hotel to conference center? All that I do is I take out my navigation system, could be my phone, and in that phone I tell where I'm supposed to go. I don't even have to tell where I am and anything else. And I start getting directions. Navigation is nothing but sequence of recommendations. Take this action at this point. Now you are at this point, take this action. Now take this action, and so on. But how do I solve the second problem? There is right now no good solution for this. This is a serious problem, and this can only be solved by building food recommendation systems. I did work with Weijing and Suchiang to collect information about what exists. And believe me, very little, very, very little. Okay? But we did write a survey paper for that kind of thing. This is the real problem. Like any recommendation system, there are three components. There are the items, what food item I should be eating. There is the context, or even before context, let's consider personal model, who the person is. I cannot make a recommendation without knowing the characteristics of a person. I cannot make recommendation without knowing characteristics of items, and context plays a very important role. Once I have all this information and I start implementing a recommendation system, the output is always going to be a list of items. Okay? So this is what I start doing. Luckily, context part is the easiest part. We have to know the location, what are the local regulations, seasonal variations, personal history of the person, where did I eat yesterday, where did I eat day before yesterday, and so on, who is in my company, and how much I can afford. These things are the easier part. And I will not talk about these things. Anybody who knows the recommendation engine can go and start building. But the other two things become very important. Most of us equate eating well to eating healthy. Unfortunately, most of the fun foods happen to be fatty foods filled with carbohydrates and sugar and salt and fats. Eh, They are not supposed to be good for me, but I like to eat them. On the other hand, healthy food, I don't like to eat them, but they are good for my body. And that brings a very important issue. Does eating well mean eating tasteless food? And one of the things that I'm trying to convey to you today is that is not true. Eating well does not mean eating tasteless. The question is, how do we do this? Yeah. We face this dilemma whether we are going to go for enjoyment or we are going to go for health. That's what at least we start thinking. And that brings a very important problem to all of us. And that problem I started calling my stomach and my tongue problem. Like mind body problem, let's call it body and taste problem. What I like to eat is not what my body wants me to eat. And this is very interesting because that puts us in a dilemma. What do I do? That's what we try to solve. You go to bookstores, there are millions of books. If you go to any bookstore, which you don't nowadays, but if you care to go to some bookstore, you will see there is no shortage of books on what you should eat if you have diabetes or if you have heart disease or if you have this or you don't want to gain weight and all this kind of thing. What problem with books is it's very old technology. You all are growing up with new technology, that is this. You like to deal with this rather than a book. So, what is the problem with books? These are the basic problem why books are, particularly in this context, not useful. They are not actionable. If I want to eat something and I have to spend half an hour reading and trying to find whether this is good for me or bad for me, forget it. More importantly, they are not personal. They are written for population. They are not written for my body. And they do not capture context. A book does not know that, yes, broccoli is good for you, but you cannot get broccoli in New Delhi. Nobody eats broccoli there. So, the important thing that we want is people want right information at right time in right form. That's why this device is becoming very important. And as I mentioned to you, how do you go from one place to the other? In navigation system, now you don't have to struggle with maps. Now you don't have to fiddle around and look for directions by finding out the maps. Somebody does all that in the cloud and sends you only actionable information in the context that you are. And that's what is the most important thing. So, as we discussed, one of the biggest problem is how do we find this and food items? And in order to select this or food items, we have to find what kind of ingredients are in the food. How will they taste? What is their effect on our body in terms of nutrition and calories? But how will they taste? Same ingredients in different season taste different, and depending on how it is cooked, it may taste completely different. How much different volumes are of particular items are put in an item. So all these things start deciding these things. And they also decide the cost and things like that. The second challenge that we need to face is the person. Who is the person going to be eating this thing? And for this, we have to know the preference of the person, what he or she likes or dislikes, what are the social and religious preferences, what the person can eat or not eat. But the same thing you have to do for health. For some people, the same thing may be bad. For some people, it may be very, very good. How do you know what kind of items are good for me and what kind of items are bad for me? Okay. Recent history, what I have been eating, because if I'm eating the same thing too many times and which is not good for me, it may really hurt my health. Forget about enjoyment part for the time being, but it may hurt my health and I'm not going to enjoy that too. So you want to start mixing up different things. And then, of course, you have to consider in whose company you are and what is the budget. Okay? So the question is, how can we get this information, particularly the first and second bullets, and the third bullet also here? What does the person likes and dislikes? What does social and religious preferences are? Which food affects my health in a particular way? And what I have been eating. If I eat some more things, I'm going to get acid reflux. Or if I'm going to eat something, uh, uh, now it is going to increase my sugar level. So the question that you start asking, if every person is different, then can we know a person? Very good question. How can I understand what this person likes and doesn't like on a hot day, on a cold day, under different circumstances, and what does this person's body likes and doesn't like? So one of the things that you start thinking is anybody building models? And you realize that almost every company in any country that is successful in the last few decades, particularly last 2 decades, knows a lot about us. All the businesses understand their customers. They know a lot more about us than we ourselves do. So when you start considering different aspects of a person, these are some of the important aspects that you need to find out, particularly in the context of food. We have to find all these factors about a person. So how do we find out this thing? We build a personal food model. We collect enough information from different sources, which is now possible. Okay? You have this device, you have this device in my finger, and you have device on my hand, and you have social media, you have all kind of places. You start collecting all this information. Okay? And using this information, you can start building personal food model. So some people, some students in the lab here at UCI, we started thinking about this problem and we started implementing this. In last year's ACM Multimedia, we presented a paper on personal food model, where you look at this thing and start thinking how to build the personal food model. And that's what I'm going to describe a little bit. This personal food model has two components, as I have been arguing, that enjoyment and my body. This particular part that we call preferential part is related to how the user's taste preference profile changes in different contexts. What I like, under what circumstances, and so on. On the other hand, this biological model, it tells you which food is going to affect my body in which particular way particularly if I have any kind of chronic disease, I haven't been able to sleep well, or my weight and things like that. These are the two important aspects. If you recall, when I talked about user-centric model and I put the joy and the body or health on two sides, these are the two things now. This is what we want to build. Okay? In order to do this, the most important thing is to create something called food chronicle. What is a food chronicle? Traditionally, for the long time, people used to create a diary. They called food log or food diary. Oops. Okay. So they created this diary. It became now slightly more modern with your computers. Go to MyFitnessPal or any of the things, or even in your Apple Watch. They give you facility to enter what you are eating and how many calories are there, etc. You can call it food database. But we are from computer vision, from multimedia, and from modern machine learning and AI tools. We are not going to be bogged down by these two things. We are going to use modern techniques. So we are going to do the scanning code, or we can take a picture. But these things are not very good. They are all very unsatisfactory. Let me give you a very simple example. 15, 20 years ago, when you wanted to find out what activity a person is doing at home, what did you do? You always thought about putting a camera or putting some sensors in the home and observe the person. What do you do now? You put this device or this device and you use this device. They are continuously finding out using accelerometer, gyroscope, my heart rate monitoring system, and very soon glucose monitoring systems and all this kind of thing. What is happening with me? But for food, we cannot do this. It still remains a challenge. We realize this, food logging is a challenge, but we have to solve this problem. So we started adopting that food logging should be a platform. Food logging is not a camera. Food logging is not microphone. Food logging is not a barcode scanner. Food logging is not entering text or putting a sensor here to see what is my mouth movement. Or as some people are trying to do research, putting a simple sensor behind my teeth and trying to find out how fatty food I'm eating or how much sugar and salt I'm eating. It's going to be a platform that will start combining all these kind of questions. This platform that we call food logger gets input from many kind of places, including when I'm eating, where I'm eating, and all this kind of things. It accesses different databases to find out if I'm at this location at this particular time, how is the weather? Or it finds out if I'm eating this dish at McDonald's and this dish at this particular restaurant, how much is the nutrients in that kind of thing. Limited, but it can start doing this thing. So we combine all these type of things to start creating this food logger. We are implementing an open source logger that we will make available in the next 2 to 3 months. If you are really interested in experimenting, you can already get this. We call it UCI food logger. On the front page, when you go, it will tell you about what you have been eating today, what your different conditions are. To enter the food item, as you see here, right now it uses text, barcode scanner, microphone, and very soon camera. You can tell how much you are eating and how much do you like the food. Because this like is very important to build your food model. Amount is very important to know exactly how much calories and what kind of nutrition you are getting. We can also enter some simple information, because for diabetes or for acid reflux or for mental health, these kind of things are very important. So we can collect that information, and we can, because many times we eat at home, and when we eat at home, we use our own recipes. So can we create this system so that you can enter recipes, you can modify existing recipes by telling what item you are going to change and start putting these things. We are also collaborating in this area with University of Tokyo. Particularly, she has been working with Kyo Aizawa, but recently she has been working much more on recipes. She has developed a very interesting system for recipes that we are modifying and adopting in our own work, and we are collaborating with them. So this is what the food logger application starts looking like, that we enter all these kind of things, collect all this information, and then this tells us what food items we are eating, where we are eating, when did we eat, what kind of environment was there, and all kind of information sources for this kind of thing. So we collect all this information. We realize that in solving this problem that I have been mentioning, there are two grand challenges. Number one is creating a detailed food model for a person. That's what I've been discussing. And creating a detailed world food atlas that I discussed a few minutes ago. Okay? Both of these things are going to require a lot of efforts. No one research group will be able to do this. Okay? And that's what we are trying to do. So important thing is, how do we find satisfactory food in a given context? We started building a system some time ago. We crawled every restaurant in California, went through their menus, and wherever possible, we tried to find out what recipe they are using and what are the ingredients. And based on that, we try to analyze the calorie and health structure. We need to do this for the whole world. We started a project again with University of Tokyo, and soon we are involving some others to universities. We call it the World Food Atlas Project. It should tell me, like the atlas, that you are at this moment sitting at this particular place. Within some distance of you, these are the food items available, either from restaurants or from grocery stores or some places. And you can bring those kind of things. And for this, a very important thing will be food knowledge graph. We all have seen the efficiency and effectiveness of knowledge graphs in search. Can we create food knowledge graphs? Because World Food Atlas will depend on food knowledge graph. This is a typical knowledge graph diagram, because many of us are researchers here. This is showing what an author is, what kind of things is, where does the author belong, with university or with organization, what kind of profile the author has, what kind of articles the author has written, and where is he getting his funding and things like that. This kind of things. For this, in order to prepare a food graph, we start considering that this, what are the ingredients, what are the test vectors, how much calories are there, what recipe was used to prepare this thing, which culinary class this particular thing belongs, and things like that. Effectively, for creating food knowledge graph, we have to collect data and knowledge from ontologies, nutrition, health and taste, recipes, and ingredients. And when you start doing this, there are some early stages of things available. So you can start implementing a simple thing. For example, this is showing a knowledge graph of something. This particular ingredient is pig, or from there you are having different types of ham. This ingredient on this side is the pineapple. And using this knowledge graph, now you can start finding out which dishes are made using these two things. And you can go and start creating more information about this. Okay? This is what the food atlas will be. In this, a very important thing is, how do we understand the taste? And for taste, we will have started considering, remember, in taste, we are not considering how does the food smell, what is the texture of food in your mouth, and all kind of things. It is much simpler thing. And that is 6 different tastes. And you take these tastes and start finding out the component of these tastes in this. That means what you start doing is, if you want to find taste of a dish, you have to start doing the following thing. In food database, there are already multiple databases available which lists all the ingredients. And in those ingredients, it goes through all the chemicals in those things and lists how will they taste. And when you start considering that you want to now understand how will a particular dish taste, what you need to do is you have to find out what are the ingredients, what is the proportion of those things. I will not go through this complete diagram, it will take us too much time. But basically, you take these ingredients, combine this, and we are training a diagram. US4B stands for umami, sweet, sour, salty, and spicy, and bitter. These 6 tastes you start considering. I'm showing only a 3-dimensional version of this particular thing here. So based on all these things, we derive the 6-dimensional vector for each dish. Remember, for each ingredient, that 6-dimensional vector is given in terms of chemicals, and from chemicals you have to derive this 6-dimensional thing, and then you can combine these things based on the proportion of these things, based on the process that you have used, and prepare this. So in the 6-dimensional space, which I'm showing only 3 dimensions here, you start seeing that different points will represent now different types of recipes used to prepare different dishes. Okay. So this is what Ali is working on. This starts now creating taste for a dish. Now, if I know what a particular person likes to eat, you remember in food logger, it says how much you like that particular item. If I'm collecting that information, then I can go to the same space, US4B space, and find out which are the green areas, that is the area that this particular person likes, which are the red area that this person doesn't like. Okay. And what are the don't care areas and things like that. And based on this, now you start collecting this. Okay. So you start doing this, and you come here. You have 2 things now. This is a food item taste space, and this is a person taste space. You have to do the matching, and that's it. Okay. So other things that we need to do is, this is again a very complicated diagram related to event mining. A personal advertisement. Just last week, ACM Press published a book on event mining that was co-authored by my PhD student who graduated 4 years ago and myself. And we are using this kind of approaches there. The basic idea is, if you have the data over time about sleep, food, exercise, and stress, and all this kind of thing, and you know what is happening to the person, then you can start collecting this data to find out what food item allows a person to sleep well, what food item does not allow the person to sleep well. Now, this information is correlation. If you want to convert this to causality, then you use books and research papers and the knowledge about this kind of thing. And you go and start analyzing all these things. So there is a hypothesis formation phase. We generated a hypothesis, and then we go and do the hypothesis verification. And based on this, we come up with a particular person food model. There are 2 food models. One is the biological personal food model, that whenever this person obvious things like eats high carbohydrate food with very little exercise, weight increases. But then it also finds relationship between humidity and sleep. Okay? It also starts finding out that oil-rich food alone is not bad for acid reflux, but oil-rich food with alcohol could be bad for acid reflux and things like this. And this is all based on the food log as well as all that knowledge, event mining component. Yeah? And you go and find out about this person's food habit, food things, what he likes, what she likes, and things like that. So this thing is available. This can give you very good insights. For example, if a person is having difficulty sleeping well, which many times we have, and we start thinking, am I under stress? Am I worrying too much about this deadline? What is it that is causing this kind of thing? But if I have this data that we are talking about, this data can be used to find out that for me or for this particular person, there is a very simple rule. Spicy food and 2 glasses of wine results in sleepless nights. Why does this make sense? Because 2 glasses of wine and spicy food may result in very bad acid reflux, and bad acid reflux, if consumed before uh, dinner, is going to result in sleepless night. So what will the system do for me? As soon as I'm entering Indian restaurant, my system will come and tell me, see, you are going to be at an Indian restaurant. Don't drink wine or don't drink much wine. Okay. So this is the grand challenges for food recommendation system. Creating a detailed food model for a person and creating a world food atlas. Okay. And that's what we are trying to do. We are working on both these problems. The one particular problem of creating this food atlas is really much more challenging than anything. And this requires people from all over the world to start working together. And when you try to do this, I would love to hear from you. I would love to work with you on this kind of problem. So thank you very much. I very strongly believe food is life. And the way things are going, soon you will have your cars tell you where should you go to eat and where you should not go.
Okay, thank you very much to Professor Jain for a wonderful talk. Actually, even though I know him, I claim to know him well, but this is a surprise to me, Ramesh. Actually, you have done such a wonderful job in terms of the this new dimension of health monitoring, and also not just health monitoring. I think you're much more than his personal flavor. And you present two challenges, and that's really this grand challenge. I think that we do need an entire worldwide community to work on. So I do have a few questions coming to my screen here, and I will ask on behalf of the audience. Okay. So I think the first question was, what is the criteria that the food needs? Food needs circle is ordered. I'm reading this, but can you get meaning out of it? Or I actually not completely understand the question.
What is the major difference between the food recommendation system and other recommendations? Okay.
Okay.
Okay. In fact, that's a very, very good question. Recommendation systems are making very good progress. As I pointed out, in any recommendation system, there are three components: items, person, and context. And all those three components are there. In any new recommendation system, you have to analyze what these things are. And as I tried to show you in this paper, and that Chang Wen was calling two grand challenges, Those two grand challenges are, how do you characterize items? Because food items have not been characterized well. The same Kung Po chicken eaten in New York and eaten in San Francisco and eaten in Beijing or eaten in Hong Kong tastes very different. Its ingredients may be different, uh, and its calorie content and nutrition content will be different, though it is the same dish. Yeah. So how do we do that? And that's where the World Food Atlas comes into picture. And the next part is the person. If you are doing the movie recommendation or if you are doing Amazon type recommendation, it's very easy to find preferences of the people. But here, in this kind of application, finding the preferences of the person and finding which particular food is going to affect my body, how much, and then trying to combine them in the correct proportion is very difficult. In recommendation engines, that has not been done, where you consider both the quantity and combination of different items to prepare one thing. Okay. And
Okay, let me interrupt. I think you have already given enough for that question. The next question comes: what is the major challenge in food logging?
Say it again.
What is the major challenge when we do food logging?
The biggest.
I think the concern is, you are play too much with the, your iPhone and other things, and sometimes may be difficult for certain populations.
In fact, the biggest challenge that comes in food logging is the following. As we know, nowadays, if you ask me how much exercise I do or how much I walk, I don't have to think and I don't have to do absolutely anything. My system is automatically recording that information. Even for the exercise, the systems based on accelerometer and other things are determining whether I'm walking, whether I'm jogging, whether I'm running. My watch even tells me after if I am walking outdoors 7 or 8 minutes, my watch comes back and asks me, are you walking outdoors? Should I start logging this as exercise of walking outdoors? If I'm trying to do something, my watch starts asking me, are you sleeping, swimming, and things like that. So these things can be automatically determined. For food, we don't have anything like that. For food, I have to take out my phone or I have to tell that I'm doing this. Most of the time, people forget. That is the biggest problem. Computer vision systems were not very good until very recently. But in the last 2 years, I have seen some companies that, and I have played with their system. It's reasonably good. They can even determine what are the items on my dish. But if you are eating a dumpling, what is inside the dumpling? How do you find out? Okay. Now you have to start combining that information with the restaurant information and possibly get some more information from your bill and things like that. So it's not a problem that can be solved using one sensor. It is a problem that will start combining information from many different sources. And we don't even know today what are those sources. But my doctor friends tell me that if you can tell me that this person is eating at McDonald's 10 times in a week or is eating 10 times in a year, that is good enough information for me to start giving some advice. It will not be very precise advice, but that is good information that is better than not knowing anything. So we have to make slow progress in this direction.
Okay, I think I'll skip the next few questions because they're all related to the food logging, and I think you already answered some of them already. The next question coming that is there any internet companies that adopt this kind of things for the personal food recommendation? Do you know anything yet, or are these companies all in the startup mode?
In fact, there are many established companies that are having some form of uh, food logging or some form of food model. Weight Watchers does that job. They have database of all the restaurants and they have classified the restaurant food, but they cannot do the recipes, etc. And they cannot do the thing about when did you eat, etc. All the things. MyFitnessPal recently started, they used to ask you for entering your food, but they recently started using Pasio. Pasio Life, I think that's the full name of the company. Passio Life, Pasio Life, which does computer vision based thing. This came, interestingly enough, Changwen, this came from Sarnath Labs. And Sarnath Labs did this spin-off that became slowly Pasio. And it does very good job in food recognition component. And they did so good job that MyFitnessPal's, all the users are nowadays using. So Pasio Life claims that they have more than 250,000 users using almost every day their system.
Wow, great. Yeah, I think the audience may not know my connection with SunOp, but anyway, thank you for reminding me now. Those are the good years and also very challenging years. Anyway, the next question comes at, they're asking that it looks like sleeping quality is not limited to owning food factors. How can you control the other factors from the getting data?
In fact, if you saw, if you look at the slides carefully, you saw that in addition to the food, it considered exercise. It also considered at what time did you eat the food. And there is enough research in the literature that says that if you eat this many hours before you sleep, this kind of food, this is how your food sleep quality will be affected and things like that. So the question is good in the sense that sleep, but for that matter, everything else is combination of multiple factors. Food is one major factor, but in almost every case, amount of stress, amount of sleep, and you will be surprised. 3 or 4 years ago, 3 or 4 years ago, the Nobel Prize was given for relating circadian rhythm to your exercise and your food. So now it is very well known that mm, depending on when you eat food, it has different effect on your body. You can eat the same food in morning, and its effect will be very different than if you eat it in the evening.
Okay, great. Next question is coming from me, following up on this question. I think you are showing that the food impact the other behaviors, and I think I also I have a question. I think you might want to confirm that your mood, your emotional status also may change your preference on certain date and certain time on a certain food. Correct?
In fact, it's both ways related.
Right.
Depending on your mood and depending on your stress level, you go for particular kinds of food. And depending on what you eat, your mood or stress level gets affected. And there is enough literature on both these aspects. The question is, how do you find it for an individual? Because the literature is for population. You have to find it for each individual because those parameters for each individual are different. And one of the biggest problems that we face right now is almost in every part of life, we always consider population, and we consider that we or an individual is a sample of the population, which is completely wrong approach. It is exactly opposite of what should be. By aggregating behavior of people, you should form population. If you just look at me and say, Here is a person about 70-year-old Indian guy, and you try to superimpose behavior of 70-year-old Indian person on me, you will go very wrong, because for the last 50 years, I haven't lived in India. I have been living at entirely different places, and my lifestyle has been completely different. My food habits are completely different. My lifestyle is different. So I'm considering me as a person who is Indian of 70 years age is not a right thing to do. And that is true for you and for everybody else.
Okay. I think the next question I'll skip because the question was, is there any computer vision technology for the food computing? I think you already given plenty of examples, especially during this question under question. But the next one coming in, I think we'll probably close after the next question. Is the question was body type among one of the parameters for the personal food health model here? Because according to the Chinese medicine history, different food will have different effect on body types. And I'm not sure what is body type here, but I think it is we have in China we say, oh, you probably the more like on the cold side, or you are more on weak side, or those are probably the body type they're talking about. So the question is the body type among the parameters, but if they do, but my question associated with that is how do you identify the body type?
In fact, this is a very interesting question. I studied the book on Chinese medicine. So I studied also Ayurveda to understand how these things work. And when in my understanding, when the Chinese medicine talks about body type, what they have done is that they clustered different types of body behaviors based on their empirical observations. And they said, if you belong to this particular cluster, then this is how you are going to behave, which is next best thing than not having any information about a person. The best thing is if I know that each individual is center of a cluster, and I know your own behavior. So I create your own model, and then I decide exactly how you will be behaving. That means you are your own body type. There is nobody else who are exactly your body type.
Very good. I guess that's also related to the blood type too, if we are wanting to extend that. Okay, I think time is, we over some time, but I think we all enjoy your talk and also your conversation after the talk. And I can see that, people are actually very much interested in both food for health reason and for the enjoyment reason. I think the good things for many of the audience here, especially young students, you can see that our computing research can be very interesting. It's probably impact daily life of yourself, and also we are making connections between all this this 1,000 years old food technology and then probably with the computing. And I think Professor Jain is the leading person in this area, and I like to thank Professor Jain for his wonderful talk, and I hope very soon we can host you in Hong Kong to enjoy the food. This is the food paradise of the world here. So I hope during that time you can give us live demos of how is the food computing is. Okay. Thank you very much, Ramesh.
Thank you very much. I really enjoyed it. And if anybody has any questions, just shoot me a mail. I would be happy.
Okay, have a nice evening. And our chair is saying hello to you. Yeah. Okay. Well, with that, I think that we conclude today's distinguished seminar. Okay, again, thank you, the Professor Ramesh Jain for giving us a wonderful talk. And I know our chair will send you some token appreciation following that. Okay, thank you.
Thank you very
Thank
much.
you.
Thank you.
Yeah.